Hello everyone, I'm Rahul Sandalia. In this new lecture of Internet of Things, we will discuss REST architecture or style, that is representational state transfer architecture style. So, what is the importance of REST architecture in IoT? Let's see this. First of all, let's define what is representational state transfer. So representative state transfer is architectural style behind the web, defined in 2000 uh, by Roy Fielding PhD thesis. REST defined a set of rules and principles that all elements of the architecture must conform to in order to build web applications that scale well in terms of scalability, robustness. So in 2000s, when the web became very popular, means all the web started from early 90s. In 2000, it reached its popularity at very high level. So during that time, Roy Fielding defined set of rules. What should be the architecture of the web, and that is a web that become very popular. His thesis become very popular and provide guidelines for designing the web architecture. So what does REST and this architecture basically support two things. Scalability means your web system, your system uh, can be easily expanded when the number of consumers become more, number of users become more, and robustness. That means it can handle every unusual, every new challenges. Every new challenge is very easily incorporated in this architecture. So how should design our web architecture? This is defined by our REST architecture. So in this picture we can see basic architecture of the REST. That is, we can separate our design client and say server side. On the server side, basically your application interact with using important HTTP verb, that is get, post, patch, and using this it is resource oriented architecture. That means on everything that reside on your server side is a resource, and there is unique identity for that resource. And the application use HTTP protocol and HTTP verb to transfer this resource state to the client side, and the client send a further request. So response is when the REST API has what it needs, send back a response. In this picture, we can easily see the REST architecture of the web. So REST architecture. The principle of separation of concern is a fundamental of the REST architecture. The client side is very much separated from the server side. Data came in so that they can it is modular and can be developed separately by different teams. So according to this principle, each element of the system is responsible for a specific concern. Well-separated concerns allow for modularity, reusability, and independent evolution of the system's element. So main component, the main of the systems are client, that is your user agent or such as browser with your application interface and initiate interaction. Then we have server, original server, host resources, and serve client requests. A REST architecture is characterized by uniform interface. All connectors within the REST must conform this interface constantly collectively. REST define the following principles: identification of the resource, manipulation of resource through representation, and self-descripting message. Hypermedia as the engine of application state. So we will discuss this 4 point in detail, but this 4 point is very important. This identifies the REST architecture, that every resource has must have some. Think your application in terms of resource, and every resource has what is the resource? That is everything that has a unique identity. That is your URL. can be treated as resource. Manipulation of resource through representation. This representation can be form of say JSON, XML. So this resources can be represented, can have some represented form. That it can take the form of HTML page, it can take the form of JSON or XML. Self-descriptive messages. So it must have say documentation that describe what verb are defined for these resources. Means you can use get, post, put, patch. These are self-describable, and what this resource provides. Hypermedia as the engine of application state. So how this state, the state of the client changes? It is because this representation has linked to another representation, another state. So using this hypermedia, the state can transfer to and fro between client and server. Representation of the resources. Resources are never exchanged directly by the endpoint. Instead, representation of the resource are exchanged between endpoints. Representation is a view of the state of the resource at a given time. So what is the representation? A view of a state resource at a given time. For example, say you have image and that is stored on the text. It has some URL. But what is its representation? You can how you will send this image to the client. Basically, you can tag it in HTML image tag and provide height, width, extra some meta information, and that is helpful for its representatives on the client side. So this representation is view how this resource is represented to the client. That is basically the representation of the state of the resource at a given time. This view can be encoded in one or more transferable formats such as XHTML, ATM, XML, JSON, plain text, comma, etc. So we have multiple say formats for this representation, and it is transferable. Means in this format we can send our resource from server to the client. Typically, the type of representation is specified in one header of the message, that is the content type. Every time if you access any API using the curl tools or Python HTTP tools, you will see that it defines the content type header. We define what is the kind, what is the type of the resource. What is the type of say representation? Resources are exchanged back and forth between client and server. In order to be exchanged, resource must be serialized properly at the endpoint. The same source can have many different representations, that is one-to-n relationship. In the state of same sensor can be described using JSON, XML, or any. So as I have told, that resource is something that has unique identity, but this resource can have multiple representations. It can be sent to the client using JSON format, it can be sent to the client using XML or HTML format. Resource, and so the first one was the representation. Now the second important thing is the resource identifier. In order to ensure that an application is handling the correct resource, a mechanism to identify a resource univocally in the network is necessary, and uniform resource identifier does this. Service provide this specific needs. A URI identify a resource univocally. A URI can be used to address a resource so that it can be located, retrieved, and manipulated. There is a one-to-n relationship between resource and URI. Means a resource can be mapped to multiple URI, but URI point to exactly one resource. This is very important, that a resource can have multiple URI, but every URI is mapped to indicate only to one resources. URI can be of two kinds: a uniform resource name URN, name of resources, that is and then URL, uniform resource locator. Specify the URL is the more important one, popular one. Or URL takes the format of a scheme called a scheme specifics part. The scheme part defines how the rest of the URL is to be interpreted. It typically serves as an indication of the communication protocol that is that we can see here. Like a scheme is the HTTP part, and a scheme specific uh, should be used to target the resources. So URL include all the information needed to successfully address the resources. The host and optional port include networking information needed to reach that resource. The host can be either an IP address or a fully qualified domain name, which must be resolved using the DNS system. As we can see, a URL can be break into this scheme. A scheme is basically indicate the protocol. And then we have host name, then we have port name. Host name describe the basically using DNS you can using this host name you can identify what is the IP, and this port, the port defines your process ID, say your application, and rest of is the identification of your resource. So the path provide information to locate the resource inside the host. The query contains the mapping information to filter out the result. The fragment can be used to identify a specific portion of the resources. Then we have this fragment part. This can be used to identify a specific portion of the resources. URI should be opaque and not expose any specific notion of the format used to represent the target resource. Now, the next important characteristics of REST architecture is that the REST is stateless. That means an important principle of REST is stateless. The statelessness implies that no state information must be kept on client and server side. So the state information is not kept on the client and server side, thus avoiding the need to use cookies or to introduce the concept of sessions. So as much it is possible to avoid the use of cookies or concept of session. This is ideal. In real we use sessions and cookies often, but its use is avoided, which demands a strict coupling between the endpoints. So using this, the endpoints are coupled, and the principle of REST architecture is that the endpoints should be decoupled. All requests must therefore be stateless. That means once a client makes a request and the server provide that fulfill that request, the next request doesn't know about the previous request. So this is the stateless. Next request doesn't know about the previous request. In order to preserve a statelessness, each message must be self-descriptive. This means that all requests must contain all information to understand the request so that the server can process them without context. There is no state information maintained between the client and servers. The state of the client is contained in the request, so the server is relieved from the burden of keeping track of the client state. So next important concept is the application as a finite-state machine. So the state of the application, that if you look at the browser pages of particular say service provider, say web service, you can think of client request as a finite-state machine. Every page is one state, and the next state can be linked using the hypermedia connection, and in this way the client state is transferred from one state to another state. Due to the loose coupling between client and server, the state of the FSM and transition between them are not known in advance. The state is reached when the server transfer to a representation. So you can have, if you are in a particular state, you don't know about every other state. You only know those state which is directly linked to this state. So there is no say information stored in advances. That is the mean by what we mean by stateless. A state is reached when the server transfers a representation of the resource as a consequence of client request. The next possible transitions are discovered when the application reaches a new state. Resource representation that embed links are called hypermedia. So what is hypermedia? Basically, it is the resource representation that embed links. These links represent possible transition to the next state. So how one state is transferred to the next state? It is using the hypermedia. In essence, the state of the resource identified by a URL is contained in the data section of the resource representation, and the transition to the next state are contained in links. So next, the feature of the REST architecture is that hypermedia as the engine of application state. The final principle of REST is hypermedia as the engine of the state. So this state is basically defined or represented by in terms of hypermedia. So hypermedia, as we know, is a media means representation which linked has linked to other representation. A hate EOS hypermedia as the engine of application state. Hypermedia as engine of application state. This word is important. Hate OS. State that the resource representation should include all the information to drive the client to perform the next request to progress in the application. A client just need to follow the instruction that servers transmit in order to reach its goal. This guarantees that should the server change its implementation and introduce new functionality, stateless, the client would be unaffected by these changes and continue to operate. So basically, the hypermedia says that a single state has all the information that is required, that is necessary to link it to the other state. Means, for example, if you have, say, to form to for example, you have home page. Home page has all the links to different part of the services. So if you have to move on the profile, you can it has profile link. So basically, and if you goes to the profile page, then you have links for the important links. After going to profile, we have you have link for, say, sign, change your status, change your profile picture. So every page has all the necessary link that is required to change the status, the immediate state. So, and another features this is important is the HTTP hypertext protocol. Using this protocol, the state is the client request is fulfilled. We have important request that post create a resource when you don't know URL, password, update. That is when we create the information in database. That is when we fulfill a form. So post request is used to do that. Then we have get, that retrieve representation. Put, create a resource at known URL or update an existing resource by replacing it. So put is basically when create the resource or update it. Delete a resource. Get and container using a path hierarchy. Get perform, get a container using the path hierarchy. So list to retrieve a data. CRUD operation basically perform the post, get, put, delete. If you have to partially update, we have another word called batch, and list. Get is also used to list all those list of the data. In summary, REST application progress according to the following steps. The client starts from the entry URL or a bookmark. The response to the GET request include a hypermedia representation. The representation contains links that define the possible transition to the next state of the application. The client select a link to the follower and issue the next request. That is, it triggers a transition to the next state. The client can also go back. So what are the advantage of the REST API? Means REST architecture. REST web services are easier to learn, more intuitive, and more suitable for programming IoT applications. The main advantage of REST are simplicity. Since REST uses a standard HTTP, it is much simpler, demanding, that is minimum tooling, middleware. The variety of data formats. REST permits many different data formats, while SOP, that is SOP is another form of web service that is basically service oriented architecture that follow SOP protocol. And SOP is not define the basically architecture. REST define architecture, while SOP is fully a protocol that follows service oriented architecture. SOP permits XML only. In just such a way, REST allows better support for browser client due to it is support JSON, HTML, simple text, many content. Performance and scalability. REST has better performance and scalability characteristics. REST architecture has intuitive flexibility, better cache support. REST is stateless. That means it is can be cached. Okay, lightweight request and response and easier response path. So in this next video, we will see why REST architecture is important for IoT. We will look REST at in a different light, from different angle, so that we can see the importance of the REST architecture for our IoT system.